Hello everyone. When it comes to balancing redox reaction, especially when it comes to balancing the redox reaction using the oxidation number, many students have a lot of confusion, a lot of misunderstanding, and then they think it's too difficult. How can I try to solve this using oxidation number, and do I use trial method? Do I try one by one? Won't it be time consuming to do that, and so on? Okay, I'm going to teach you a trick when it comes to balancing redox reaction using oxidation number. I think the trick is very simple. This is an update to the video that I've done in the past. Maybe some of you still confused. So probably I'll actually modify the method, and I came up with a new way to teach, and I'm going to actually share it over here. Probably this is going to be much more easier to understand. And I will start using a simple example here. Okay, here we are going to try to balance this equation, and the answers are there. Okay, so that later we can compare our answers. But here, okay, whenever you have an equation, it is very important to see, okay, what we want to do. So basically, we need to find out which one is going to be oxidized, which one is going to be reduced. So please calculate this yourself. Okay, the oxidation number of this Fe is going to be +2. This is going to be +3. So I found out that +2 to become +3, that's going to be oxidation. Okay, so the oxidation, I will write down the oxidation equation is going to be Fe2 plus. Okay, this one assuming that I do not know there is 5 over there. Yeah? So I'm going to actually try to balance the equation. So Fe2 plus to become Fe3 plus is an oxidation. So I need to find out which one is going to be reduction. So for reduction, okay, this one you can calculate yourself as well. This is supposed to be +7, and this is going to be +2. So there is going to be MnO4 is changing, okay, into Mn2 plus. Now, so what we need to do over here is, okay, you just write down, this is going to be +2, +3. This is going to be +7. This is +2. So what is happening when it comes to the oxidation and reduction? Okay, this is going to be oxidation. So the increase by 1 unit, and this is going to be decreased by 5 units. Okay, please remember this. Now, when it comes to oxidation and reduction, we need to know that in terms of electrons, okay, oil rig, you can remember this, okay, oil rig, okay, oxidation is loss of electron, reduction is gain of electron. So in this case, okay, I can say that Fe2 plus, okay, every one, okay, because there's 1 mole over there, every 1 mole of Fe2 plus has lost, okay, 1 mole of electron, okay, 1 mole of electron. And here, okay, I can notice that every 1 mole of MnO4, they have lost, okay, they have gained, reduction is gain, they have gained 5 electrons. Okay, they have gained 5 electrons. So that is very important. We have to identify that. Now, the next step is, okay, we need to find the lowest common multiple between 1 and 5, okay? So because we need to eliminate the electrons, okay? So what I'm going to do, okay, the lowest common multiple is 5 actually. So this one I'm going to times by 5. This one I'm going to just times by 1 because I can cancel off, right? 5 electrons, it will cancel off. So here, if I times by 5, okay, it means this one must be times by 5. This is also 5. Okay, this is 1, so it means 1 and 1. Simple as that. So what is next? Okay, what is next? So if I have, for example, Fe2 plus MnO4 minus plus H plus to give me Fe3 plus Mn2 plus H2O. Once I get this, okay, if I want to balance this, okay, what I need to do is, I know for now, okay, since I have calculated, I know that this is going to be 5. okay, and this is going to be 5, okay, 5 and 5. And I know that this is going to be 1, this is going to be 1. So 1, and this is going to be 1. Now, how do we balance the H plus and H2O? Now, to balance this H plus and H2O, okay, this one we need to calculate, or we need to solve this, okay, which is going to be for MnO4 minus, okay, they are going to actually give you H2O, okay, and then this is going to be H plus. So this one, okay, 4, okay, I put 4, and then this is going to be 8, okay. So I know that, okay, I times by 1, so it still remains at 8, okay, because just now I times by 1, yeah. So times by 1, this one times by 1, it still remains as 4. So the one that we balanced just now was the electrons, yeah. So this one, just put the 8 here, and just put the 4 here. And without looking at the electrons now, you have actually found out the answer. So we compare the answer now. 5, 5, 1, 8, 5, 1, and 4. Here they have given W ammonia plus X O2 to give you YNO plus ZH2O. Okay, so I'm going to actually teach you how to balance this reaction using oxidation number. Now, if you want to balance that, first you have to identify which one is reduced and which one is oxidized. In order to do that, you need to calculate the oxidation numbers. Okay, so I'm going to actually quickly calculate the oxidation number here. Okay, this N, okay, the N, okay, you can calculate X, okay. Hydrogen is always plus 1, so it's going to be 3 times 1 equals to 0, X equals to -3. And then the N over here, okay, this one if you calculate is X minus 2, oxygen is always -2 equals to 0, X equals to 2. So you can see that, okay, from here to here, okay, that's going to be -3, they are going to become 2, and you can see that it's going to be increase in oxidation number. So it's going to be oxidation. I have identified that is going to be oxidation. So I'll write down the oxidation. This is going to be the equation involving oxidation. So ammonia, okay, ammonia is going to give me NO. Okay, and then I will identify the reduction. So of course you have to, if you look over here, it's actually related to oxygen. This is going to be oxygen, okay, in element is going to be 0 oxidation number. This is going to be -2. So you can see from here to here, decrease in oxidation number. So this one is going to be reduction. So I will write down, okay, this is going to be reduction. So this using the oxidation number, I found out which one is oxidation and which one is reduction. So I will write down, okay, this is going to be the reactions that I will get. Okay, so the next part is, okay, under oxidation, if I look at the number -3 to become 2, the increase in oxidation number, that is going to be increased by 5 units. -3 plus 5 is going to be 2. So there's going to be increased by 5 units in oxidation number. And then if you look at the oxidation number for oxygen, there is going to be decreased by 2 units. So I will write down -2. Now, when it comes to the definition for oxidation and reduction, you can remember oil rig. Okay, oxidation is loss of electron. Reduction is gain of electrons. So in this case, now we are going to use the electron to identify and try to solve this reaction. So here, when we have +5, okay, it means that the loss of electron here, there is going to be 5 electrons, okay, they are going to be lost. So in this case, we are going to actually write down there's going to be 5 electrons being lost, okay. Here it means that, okay, ammonia has lost 5 electrons, so +5 electrons. Okay, forget about the nitrogen and so on, just actually leave it just like that. So it means that what I can see here, okay, because of this number, I can see that for every nitrogen, yeah, for every nitrogen atom, there is going to be 5 electron has been lost. Okay, every nitrogen atom, there's going to be 5 electrons being lost. And then if I look at the second part here, I notice that there is going to be -2. That is going to be reduction, is gain of electron. It means there's going to be 2 electrons being gained. Okay, 2 electrons being gained by one atom of oxygen. Okay, 1 atom of oxygen. So now please take note, we are not dealing with 1 atom of oxygen. Okay, please take note. This one is going to be 2 atoms of oxygen. Okay, so this one, instead of writing it that way, okay, this one is supposed to be for every 1 atom of oxygen, you are going to, okay, this one is lost, okay, and you are going to gain, okay, 2 electrons, okay, 2 electrons, okay, gain for every 1 atom. So in this case, you are going to have 2 atoms of oxygen here. So instead of going to be 2 electrons, there's going to be 4 electrons that's going to be gained. So for O2, you are going to gain 4 electrons. Now, ignore this part. We can actually balance it later. Yeah, because 2 oxygen and then 2, no need to worry about that. Now we just need to worry about the number of electrons. Now, if you look at the number of electrons, there's 5 and there's 4. Okay, so here you see on your right hand side, okay, of the equation, there's going to be 5 electrons, and then on your left hand side, there's going to be 4 electrons. So we need to actually eliminate these electrons. So how do we eliminate the electrons? Okay, we eliminate by finding the lowest common multiple. So the lowest common multiple for 5 and 4 is going to be 20. So I'm going to times this by 4, and I'm going to times this by 5. So what am I going to times actually here? Okay, I am going to times this by 5. I am going to actually times this, okay, with 4. This reaction for, I need 4. Okay, why? Because I need 20 electrons. I am going to times this by 5. It means, okay, I am going to times this by 5. The reason why I did that, because I need 20 electrons. Okay, so it will cancel. So what I get over here is, okay, as simple as this. You are going to have, okay, 4 NH3. So you just need to write this as 4. Okay, we have identified this as 4, and this is 5. So we have identified X is going to be 5. So you just need to put 5 there. So the rest, you just need to balance. Like for example, what is going to be Y? Quite simple. You have 4 nitrogen. So I just need to put 4 here. Okay, so I'll erase the Y, and I just need to put 4 here. Okay, 4 nitrogen. And then, okay, the next is going to be to balance the oxygen. The oxygen, you can see here, there's going to be 10 oxygen here. So here I have 4. I need 6 more. Okay, so how do I get 6 more oxygen? I just need to put 6 there. And the last thing is to check for hydrogen. Hydrogen, there's 12. And hydrogen here, there's 12. So this one, we have balanced the reaction, okay, by using the oxidation number. So this is going to be the balanced reaction. Here I will show you about disproportionation reaction and how we are going to use the method of using oxidation number to balance the disproportionation reaction. So if you're wondering about what is disproportionation reaction is a reaction where you have a substance and they can be both oxidized and reduced at the same time. In this case, in this example, you can see Cl2 is being oxidized and reduced. So without wasting any time, so let's actually move on and try to solve this. So in order to do this, you need to actually do the same thing. So you have to identify which one is going to be oxidized, which one is going to be reduced. So the one that is going to be oxidized, so you can look at the oxidation number. This is going to be 0. This is going to be -1. Okay, this one you need to calculate. So let's actually calculate for that. So Cl, I put X, so plus 3 times -2 is going to be -6 equals to -1. So X equals to -1 plus 6, I will get plus 5. Okay, so here I have the Cl2 change into Cl minus. So this one is going to be reduced in oxidation number, or a decrease in oxidation number. So therefore it's a reduced reaction. So if I put Cl2, okay, to give you Cl minus, that's going to be reduced. And if I write down the oxidation, I'll just put Cl2 again, yeah, Cl2, and then they are going to be giving us ClO3 minus. Okay, so we just need to put that. So here, okay, we have calculated. So this one is 0, oxidation number is 0, and then this one is going to be -1, and this is going to be +5 for the Cl. So here we can see, okay, that is going to be increased by 5 units, and this is going to be decreased by 1 unit. So here, what we need to put together is, okay, we need to actually find out in terms of electron. So oxidation is oil, this is Rig, so oxidation is loss. So this one, every 1 mole of Cl, please take note of this. Every 1 mole of Cl, they are going to lose 5 electrons. But since we are having Cl2, so every Cl2, they are going to lose 10 electrons. Please take note of this. So again, this is going to be Cl2. So every 1 mole of Cl, okay, in this case, reduction is gain of electron, they will gain how many electron? -1. So they will gain 1 electron. But since we are having Cl2, they are going to gain, okay, instead of 1 electron, they are going to gain 2 electrons. So now we need to find the lowest common multiple. Okay, the lowest common multiple that we need to look is between 10 and 2. So because we need to eliminate the electrons, so I will actually use the lowest common multiple, which is going to be 10. So I times this by 5. So when I times by 5, I will get 10 electrons, okay, and then the 10 electrons, they will actually cancel with each other. So here, okay, I'm going to actually put 5. I need to times everything by 5. So here, I'll just put 5 here, okay. This part, we can actually leave it for a while, okay. So here, I'm going to actually times by 1, okay. So this one, we leave it as 1. So what we are going to do, because this earlier, we actually separated this into Cl2 and Cl2. So what we did was 1 of it, okay, we times by 1. So this is 1. And then this Cl2, we times by 5. So times by 5. So remember, this is plus. Okay, so both of these represents together for Cl2. And if you have one Cl2, okay, one Cl2, it means you are going to get, okay, this one is going to be ClO3, okay. So what we need to do is to balance, we try to balance. So if you have one Cl2, okay, you must have 2, okay, the number 2 there. So this Y most likely is going to be 2. I just put 2 there. And then here, if this one is going to be 5 Cl2, so the Cl minus, okay, this one is going to be 5 Cl2 is going to give you the Cl minus. So it will have, okay, a total of 10 Cl minus, okay, 10 Cl minus. So we are going to use, okay, we are going to write, okay, hold on. This is going to be when we put 5, okay, we are going to times this. Okay, when we put 5, hold on, yeah, 5 Cl2, and then to give you Cl minus, so it's going to be 10. So this one is going to be 10. Okay, 10. So here, okay, if I rewrite again, do remember, okay, Cl2 and Cl2, so that's going to be 1 plus 5, so 6 Cl2, okay. I haven't find out for OH minus yet, to give you 10 Cl minus plus 2 ClO3 minus, and then we have not found out about ZH2O. So we just need to actually figure out about the OH minus and then this H2O, but the rest of it, okay, the charges has been balanced. So we just need to balance this. So what number that we need to put, okay, please take note. So this one you need to actually do trial and error, okay, or investigation investigation method. So you need to try, okay. So for example, here I have a total of, okay, if I have 2 here, so they are going to be 6O, and then hydrogen, okay. So here if I use this value as 1, okay, if I put 1, so what is going to happen, I'm going to have total of 6 oxygen plus 1, 7 oxygen. So if I have 1, then here this is going to be 2, okay. So I only have total of 2 oxygen. I don't get 7 oxygen. So definitely cannot use 1. Okay, cannot use 1. So I will try different numbers. Okay, like for example, let's say I try 2. If I try 2, I have 6 oxygen. And then if I put 2 there, I have another 2 oxygen. So I have total of 8 oxygen. So if I put 2 there, the hydrogen is going to become 4. So I need to put 4. If I put 4, I will only have on my left hand side 4 oxygen. So not suitable also. Cannot. So let's try 3. Okay, if I put 3, so I will have, okay, total of 9 oxygen. And if I put 3 here, 6 hydrogen, so this one will become 6. So I only have 6 oxygen on my left hand side. So not suitable. So let's actually try some more. Okay, 4. If I put 4, what will happen? If I put 4 here, I am going to have 4 oxygen here. So I have 6 plus 4, 10 oxygen. So if I have 10 oxygen, okay, and then I put 4, 8 hydrogen. So I need to put 8 here. So if I put 8 here on my left hand side, so you will get 8 oxygen. Okay, so here I have only 10 oxygen. So still cannot. So let's actually put 5. Okay, if I put 5, okay, I will get 5 oxygen. So I put 5 oxygen. So I'm going to get 11 oxygen. So if I put 5 there, okay, I'm going to get 10 hydrogen. So I put 10. So the oxygen is going to be 10 oxygen, 10 hydrogen. So here is going to be still not balanced. Okay, so cannot. So if I put 6, so 6, I am going to get 6 oxygen. So plus 6 oxygen, I'm going to get 12 oxygen. Okay, if I put 6 oxygen, I'm going to have 12 hydrogen there. So I'll put 12 hydrogen here. So if I put 12, there's 12 oxygen. So it's balanced now. Okay, so it's trial and error. So what I found out is I am going to get 6Cl2 plus 12 OH minus to give me 10Cl minus plus 2ClO3 minus plus 6, okay, H2O. So if I look over here, I can simplify this, okay, divide everything by 2. So when I divide by 2, I will get 3Cl2 plus 6OH minus 5Cl minus plus ClO3 minus plus 3H2O. So they want the V, X, and Y. Okay, the V is 3. Okay, and then the X is going to be 5. Okay, 3, 5. And what is going to be your Y? Y is going to be 1. So this is going to be C. So this is how we do this. It's a bit challenging. Okay, so this is going to be the method to solve for disproportionation reaction. So please take note. Let's try another example. Okay, so if you have this example, okay, they have given this and then they ask you if you try to balance this, what will be W, X, and Y. So again, okay, you just need to look at the oxidation number. So here I will calculate some of it. Okay, the oxidation number of Cl, Mn. Okay, these are the things that I will calculate. So Cl is x, so minus 6 equals to negative 1, x equals to negative 1 plus 6, so it's plus 5. So for this Cl is x minus 8 minus 1, so x equals to negative 1 plus 8, so 7. So I know that ClO3 minus, when they change it to ClO4 minus, that's going to be from 5 to become 7. That's going to be increased by 2 units. That's going to be oxidation. So for this one, I think this one, I know it's 7, okay, Mn, you can calculate. And then this one, x, okay, minus 4 equals to 0, x equals to 4, okay. So this one is, I will get MnO4 minus, changing into MnO2. So the oxidation number is plus 7 to become 4. And I can see that it's going to be decreased by 3 units. And I know that this is going to be reduction. Now, the next step is to relate with the electrons. Okay, oxidation, oil rig. Okay, so it's going to be loss. Okay, loss of how many electrons. So please take note, this is 1 mole. Yeah, so 1 mole of Cl, 1 atom of Cl, okay, they will lose, okay, 2 electrons. Loss. This is 1 mole, okay, so no problem, it's quite easy. 1 mole of Mn, they will gain how many electrons? They will gain 3 electrons. So because 1 mole and so on, so we will need to actually find the lowest common multiple. So between 2 and 3, which is going to be 6, so times by 3 times by 2. So when I times by 3 and 2, so basically this is going to be times by 3. And this is going to be times by 2. So just need to put it here. So 3. This is going to be 3. And this is going to be 2. The rest, okay, you can actually predict, okay, using the values that we have. So if you have 3 Cl on your left hand side, so of course this is going to be 3. And if you have 2 Mn over there, okay, so of course here this is going to be 2. So when it comes to oxygen and so on, if you want to balance, okay, you can see here if I have 3, 3 times 3 is 9 oxygen. 2 times 4, 8 oxygen. So here is going to be total of 17 oxygen on my left hand side. So if I put 3 times 4, it's going to be 12 oxygen. 2 and 2, 4. So I have total of 16 oxygen. So I just need 1 oxygen. So this one is going to be only 1. So what is going to be the number that I'm looking for? These are the numbers that we are looking for. But of course, they didn't want you to write everything. So, but again, we have calculated. So we just put W is going to be 3. And then X is going to be 2. And Y is going to be, in this case, you just need to balance. If this is 1, so the hydrogen wise, that's 2. So this one will be 2. So 2. The answer is going to be D. So I hope you can understand the way we do this method. So hopefully, okay, you can actually apply this method on your calculation involving balancing equations using the oxidation number. Okay, so if you like this, whatever things that I taught you over here, okay, please actually consider, okay, to like the video and subscribe to my channel. So if you are not my students, okay, you can always learn from me. So with that, okay, thank you for watching. Take care, guys. See you. Bye.